KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
Free bus for LKG to 8th standard.
Free, hygienic and nutritious food.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Education Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
Hi students, in this session we are going to discuss physical and chemical properties of amines. Actually here I written only chemical properties, but the physical properties I explain right now. See, in physical properties point of view for amines, first one is the physical state and smell. The lower aliphatic amines are gaseous with fishy odor, so fish smell. So lower aliphatic amine, for example primary amines, especially lower aliphatic amines are gaseous with fishy odor, and primary amines with 3 or more carbon atoms or liquid and still higher one are solid. Among aryl amines, the lower members are liquid while higher members are solid. See, once again I repeated the physical state and smell of the primary amines, and aliphatic category of amines are aromatic category of amines. Once again, the lower aliphatic amines are gaseous with fishy odor, and primary amines with 3 or more carbon atoms. Generally, lower means 1 or 2 is a gaseous and fishy odor, and more than 3 to 4, 5 carbon atoms of amines are liquids, and more than 5 carbon atoms of the amines are generally solids. And aryl amines also, especially in aromatic category of aryl amines also, lower members are directly liquid while higher members are solid. In the aryl amines there is no any gaseous. The physical state start from the liquid state. Okay, Nana? These are the physical state and smell. Aniline and other aryl amines are usually colorless but get colored on storage due to the atmospheric oxidation. So aniline you know NH2 C6H5, C6H5 NH2 the. Actually aniline are colorless compound, but you get colored on storage of atmospheric oxygen. If you keep it in aniline in a bottle and in atmosphere, outside of the atmosphere, it easily to changes the color. So this is the physical state and smell of the amines. The second one is boiling point. All amines except the tertiary amines are capable of the forming intermolecular hydrogen bonding due to the presence of polar NH bond. So once again repeated, all amines except 3-degree amines are capable of the forming intermolecular hydrogen bonds due to the presence of the polar NH bond. So in between nitrogen to hydrogen, polar NH bonds are there. That's why in boiling point of view, as a result of this polar NH bond, amines have higher boiling point. Write down this point, Nana. Why amines are higher boiling point? Due to the presence of polar NH bond. As a result of this, amines have the higher boiling point than the non-polar compounds of the comparable molecular masses. However, amines have lower boiling point than those of the corresponding alcohol or carboxylic acid. This is due to the reason that OH bond is more polar than the NH bond, and hence hydrogen bonds in alcohol and carboxylic acid are stronger than the hydrogen bond in amines. So ultimately nana, the boiling point of view, 1 degree amines are more boiling point, the second one 2 degree and third one 3 degree. These are the boiling points. For boiling points point of view, the presence of polar NH bonds are present in the amine, so it is show higher boiling points. Okay nana? Next, third physical property is solubility. Aliphatic amines of lower molecular masses are soluble in water. Aliphatic amines of lower molecular masses are soluble in water with increasing the molecular mass. The hydrocarbon part of the molecule becomes larger and bigger size. The solubility in water gradually decreases. The higher amines are more soluble in less polar solvent such as ether, alcohol and benzene. So finally my dear students, the solubility of the lower aliphatic amines in the water due to their capability to form hydrogen bonds with water molecule. My dear student, the solubility point of view also, primary amines are more soluble, secondary amines second category, tertiary amines the third category. So boiling point also same, the 1 degree greater than 2 degree and greater than 3 degrees. These are the general physical properties of amines, physical state and smell, boiling point and finally solubility. Now we are going to discuss chemical properties. Chemical properties of amines. See my dear students, all the three classes of amines, it's nothing but 1 degree amines and 2 degree amines or 3 degree amines have lone pair of electron on nitrogen atom, which makes them reacted as a nucleophile or base. That is the most important. Again I repeated, why amines are highly reacted na? All the three classes of amines, either 1 degree amines or 2 degree amines or 3 degree amines, have lone pair of electrons on nitrogen atom, which makes them react as a nucleophile or nucleophilic reactions or base reactions. So the first one is reactions with acid. If amines whenever reacted with acid, the salt is obtained. That's why this chemical reaction name is the reactions with acid, formation of salt. Now see nana, amines reacted with aqueous solutions of mineral acids. Write down the statement. Amines reacted with aqueous solutions of mineral acid to form salt. This reaction supported the basic nature of the amine. This reaction is supported or represented the amines containing the basic character. Now see here one general representation equation. It's alkyl amine is a primary amine. Alkyl amine reacted with hydrochloric acid, aqueous solution of mineral acid, hydrochloric acid, hence RNH2HCl. This is the combination actually, RNH2HCl. But finally how they are formed this product na, are NH3 plus Cl minus. For example, what happened in the HCl, the bond cleavage in between of the hydrogen to chlorine. Hence the chlorine is highly electronegative element to get negative charge, hydrogen positive charge. Ipo it get negative charge na, Cl minus, this positive charge na, here lone pair of electrons are present in the nitrogen atom, it's accepted the hydrogen species towards the NH2 group. Hence this kind of alkyl ammonium chloride salts are liberated. This is the most important nana. Whenever amines treated with mineral acids to form salt, to form the salts. Now see, this compound name is, my dear students, ethyl amine. It is a primary amine or 1 degree amine. Ethyl amine treated with HCl. These are the final product. This product name is, this is a salt, ethyl ammonium chloride salt. You know that very well mechanism. From the acid group, hydrogen to chlorine, the bond is cleavage, hence chlorine get negative charge and hydrogen get positive charge. If in nitrogen from the ammonia group, nitrogen contains one lone pair of electron. If the lone pair, extra lone pair of electron, it is act as a nucleophile. This nucleophile directly attack to the electrophile such as H plus, hence NH3 positive charge is formed and Cl has get a negative charge. So whenever amines treated with mineral acid, easily to give salt, this is the primary amine. In case of the cinena, this is also primary amine, but 2 moles of the primary amine treated with very powerful concentrated sulfuric acid, hence the same, or NH3 plus 2 SO4 2 minus salt is obtained. And one more example here, cinena. This is 2R2NH. 2R2NH means it is a 2 degree amine. Whenever 2 degree amine treated with mineral acid to form R2NH2 plus twice SO4 minus. All amines, either 1 degree amines or 2 degree amines or 3 degree amines, whenever treated with mineral acid, always to give the salt, different category of the salt. If 1 degree amines involved in this process, 1 degree salt is formed, alkyl group. 2 degree amines, 2 degree salt. 2 degree is nothing but here 2 different type of alkyl groups or 2 same type of alkyl groups also present here. And see these above example, first 4 example, it's belongings to the aliphatic amines. Now the last example, see my dear student, this is a 3 degree amine. Whenever treated with concentrated HNO3 nitric acid, the same salt is obtained. And see here, these first 5 examples are belongings to aliphatic amines category. The last examples are aromatic. Not only aliphatic, even aromatic amines also, whenever treated with mineral acid, it's liberated to the salts. Okay, Nana? Now here, this compound name is C6H5NH2. C6H5NH2 is aniline, you know that very well. Aniline, whenever treated with HCl, these are the product. What is this product name? Aniline ammonium chloride. Aniline ammonium chlorides are liberated. This is the first chemical properties of amines with acids, mineral acids. And second one, Nana, reactions with water. Reactions with water. See, due to the presence of lone pair of electrons or nitrogen atom, important key point, Nana, in any amine, either 1 degree amine or 2 degree amine or 3 degree amine, due to the presence of a lone pair of electrons on nitrogen atom, amines like NH3 are stronger base than the water. So here the chemical reaction in between of the amines and water. In the amine group, nitrogen, especially nitrogen, contains lone pair of electron. That's why amines like NH3 are stronger base than the water. Therefore, they are combined with water to form alkyl or aryl ammonium hydroxide. Ammonium hydroxide. These are ionized to give hydroxide ion in the solution. The aqueous solutions of amine are basic in the nature. Very, very important point, Nana. Now, either 1 degree amines or 2 degree amines or 3 degree amines, whenever treated with water, because of amine group contains 1 lone pair of electron, so comparing to the water, amines are strong base and hence hydroxyl groups are liberated. That's why in aqueous solutions of amines are basic in the nature. Aqueous solution means water. Whenever water is treated with amines, later will form the product is act as a good base, hydroxyl base. Okay, ma? Now see here, first equation, 1 degree amine treated with water. Now alkyl amine hydroxide is formed. So you know that mechanism. Alkyl amine hydroxide. Here plus, Nana. Here plus, or NH3OH minus, alkyl ammonium hydroxide. Hence, after these are converted into hydroxide. These are converted into hydroxide. Separated. Hydroxyl group is separated. Cationic group is separated. Now this is a 1 degree. Now 2 degree amines. R2NH plus HOH. Now this is alkyl amine hydroxide is formed. Later this is finally hydroxide. These hydroxides are strong base in the nature. Whenever 1 degree or 2 degree or 3 degree amine treated with water, the final product act as a good basis in the nature. Next Nana, this is the 3 degree amines treated with very clear information about the 1 degree amine or 2 degree amine, 3 degree amine. If you how to identify given compound either 1 degree or 2 degree or 3 degree, if NH2 group is present in the given organic compound, that is a 1 degree. If NH groups are present in the given organic compound, that is a 2 degree, and only N is present in the given organic compound, 3 degree. So all such as 1 degree or 2 degree or 3 degree, whenever treated with water to give base nature of the hydroxide, okay ma? This is the reactions with water. Next, third reaction, reactions with alkyl halide. Reactions with alkyl halide, generally this is a alkylation process. It's a very important reactions with alkyl halide. Now amines 1 degree, 2 degree, 3 degree amines whenever treated with alkyl halide, this entire the process name is alkylation. Now see here my dear students, the hydrogen atom of the amine group are successfully replaced by alkyl group when amines are treated with alkyl halide. The most important statement my dear student, once again I repeated the same statement, the hydrogen atom of the amine group are successfully replaced by alkyl group when amines are treated with alkyl halide. Finally, tertiary amine added one more molecule of alkyl halide to form quaternary compounds. Now see here in this equation, primary amine treated with alkyl halide, from the amine group hydrogen is replaced and also halogen group is attached to the hydrogen to remove of minus HX. So here the hydrogen atoms of amine groups are successfully replaced by the alkyl group. So 1 degree amine treated with alkyl halide to remove of one HX, hence RNHR is a 2 degree amines are liberated. These 2 degree amines again treated with hydrogen halide, 3 degree amines are liberated. Finally, this 3 degree amines again treated with RX, finally quaternary salts are liberated. So whenever amines treated with alkyl halide, the final products are the salts, but in between of the reactant to final product, 1 degree or 2 degree or 3 degree amines also liberated. Now see here example. Ethyl amine C2H5NH2, ethyl amine treated with ethyl bromide. Now diethylamine and additionally HBr is liberated. This is the generally 2 degree amine the liberated. This is 1 degree amine and treated with alkyl halide, 2 degree amine additionally liberated. HBr is eliminated. These 2 degree amines, again the 2 degree amines means diethylamine. The diethylamine again treated with ethyl bromide, triethylamines are liberated. This is the triethylamine additionally eliminated of HBr. This triethylamine is a 3 degree amine. The triethylamine again treated with ethyl bromide. Finally my dear students, tetraethyl ammonium bromide, tetraethyl ammonium bromide, it is a generally quaternary amine bromide. So these are the chemical reactions of amines with alkyl halide. And another important statement, see here, quaternary ammonium halide on treatment with moisture silver AgOHA or methylonic KOH are converted into corresponding hydroxide which are strongly based in NaOH. See Nana, this product quaternary salt, this product again treated with NaOH or AgOH or KOH, finally hydroxide groups are liberated. I didn't written that statement, just listen the statement. If see Nana, any one of the primary amine treated with alkyl halide, 2 degree amine, the 2 degree amine again treated with one more alkyl halide, 3 degree. That 3 degree amine again treated with alkyl halide, finally quaternary salts is liberated. This salt again treated with either AgOH or KOH or NaOH, finally quaternary ammonium hydroxide is liberated. This for aliphatic amine. For aromatic amines, the reactions with alkyl halide for aromatic amine. Aromatic amine also undergoes similar reaction. For example, when aniline is treated with, when aniline is heated with excess of methylene halide under pressure, form a mixture of secondary or tertiary quaternary salts. Now see here, aniline 1 degree and treated with methyl iodide and to form N-methyl aniline additionally hydrogen iodide. N-methyl aniline additionally hydrogen iodide. Now this N-methyl aniline again treated with methyl iodide on heating, N comma N dimethyl aniline is formed. N comma N dimethyl aniline is formed. This is the 2 degree aromatic amines. Now this N comma N dimethyl aniline again treated with methyl iodide, finally trimethyl anilinium iodide, and additionally this name is the quaternary salt. These are the reactions with alkyl halide for aliphatic amines, also aromatic amine. So finally, my dear students, whenever 1 degree or 2 degree or 3 degree amines treated with alkyl halide, the final one is a salt is liberated. This is the third chemical properties of amines with alkyl halide. Next, fourth chemical properties, reactions with acid chlorides and acid anhydride. Reactions with acid chlorides and acid anhydride. See Nana, here hydrogen atoms, this is nothing but acylation and acetylation. If amines treated with acid chloride, that reaction name is acylation. If amines treated with acid anhydride, that is the acetylation. Now the process of replacement of hydrogen atom of amino group by acyl group is called acylation. So write down this statement. What is the acylation, my dear student? The process of replacement of hydrogen atom of a amino group by acyl group is called acylation. Now see here with aliphatic, acylation process with aliphatic amines. Now here aliphatic amine themselves are bases. The acetylation is usually carried out in the absence of the bases. This is the primary amine, my dear student. This primary amine treated with acid chloride, listen carefully, this primary amine treated with acid chloride to form N-substituted amides and additionally HCl. For example, C2H5NH2, this is ethyl amine treated with acetyl chloride to form N-ethyl acetamide, additionally HCl is liberated. This is the acid chloride. For acid anhydride, this is the best example of acid anhydride, ethane amine, this is a C2H5NH2 ethane amine treated with acetic anhydride, this is the acetic anhydride to form N-ethyl amide. See, N-ethyl ethanamide, most important Nana, N-ethyl ethanamide is formed. So this is the acylation process. This both of them has the acylation process and also acetylation process. These three examples are belonging to aliphatic category of the amine. For aromatic category of the amine, the same concept, there is no any differ. In case of aromatic amine, aniline reacted with acid chlorides or acid anhydride in the presence of the catalyst to form corresponding amides or anilides. Most important Nana, anilines reacted with acid chlorides or acid anhydride in the presence of catalyst to form corresponding amides called anilides. Since aromatic amines are less basic and hence less nucleophilic, their acetylation is usually carried out in the presence of the pyridine catalyst. So this is a less basic nature. Aromatic compounds are less basic nature, that's why it's required the pyridine catalyst. Now see here example, aniline. This is aniline treated with acetyl chloride in the presence of the catalyst of pyridine. Hence, N-phenyl acetamide is generally name is a acetinilide. So, N-phenyl acetamide common name is a acetinilide. And see one more example here. This is for acid chloride and this is for acid anhydride. So, here aniline treated with acetic anhydride in the presence of pyridine or concentrated sulfuric acid few drops and acetic acid also few drops, and finally my dear students, acetanilide is obtained. Additionally, acetic acid is also liberated. These are the fourth chemical properties with acid chlorides and acid anhydride, that is nothing but acylation and acetylation. Okay my dear students, and remaining chemical properties I will be continuing in my next class, but in this class 4 important chemical reactions with acids and reactions with alkali halide and also reactions with acid chloride and acid anhydride. So preparation of amines and also chemical properties of amines are very important. Every student should be follow strictly all chemical properties. Do practice more than 2 times or 3 times do practice my dear student, because of if you do not practice properly, easily to forget all chemical reactions. Okay then in my next class I will be continue remaining chemical properties of amines.